Hello class, welcome to lecture 32. We will talk about procedures in this lecture page. I'm your instructor, Ms. Laura Low. We are officially moved to module 12. So in this week, the first thing we will talk about residuals in this lecture. So the next lecture, we will talk about regression inference. And the last lecture in this week, we will talk about data and privacy. So let's talk about the procedures. But before we talk about procedures, we have one thing we didn't finish from the last week lecture. We did talk about the least squares. So if we can find the list square error, so that's our regression line we're looking for. Okay. But one thing is, before we finish up the least square, let's quickly have a review from our week 11. Okay, so remember last week, actually, we start talking about the correlations. If we see two numeric variables, they have a relationship. Okay, so they have their correlation. If their relationship is the linear regression, so this, actually, we can find this linear regression if in the scatter plot, we can see this correlation between these two data attribute is linear. Okay, so then we can find the linear regression. So how to find the linear regression? We can convert the both attribute into the standard unit. If you convert to the standard unit, the linear regression, always the intercept equal to 0. If we change to the standard unit. So then your slope will be the correlation coefficient. Okay, so that's how we find the linear regression. So quickly, if you remember, that's we have, right? So we have, if that regression line is in the standard unit, also that definitely they will pass through the origin. So the slope will be the correlation coefficient. However, since we have to have our estimation, right, we have to convert both our data still in the original unit. So if we want to convert your regression line back to the original unit, so they are the same. Actually, you see, they just changed the unit, but regression line, the shape still the same. So the only thing different is they become y equal to ax plus b. So they do have intercept. And the A slope will equal to the correlation coefficient times the standard deviation of y divided by standard deviation of x. So that we get our regression line. Okay, so then, right, so continue with our regression line. Which is the best regression line? So that's why last week at the end, we talked about the least square. So then let's continue to finish for the first lecture today. So in order to find the best regression line, okay, so the first thing, we need to find the smallest error. So that's what is the error. So when we have the error in estimation, is the actual value minus the estimation, right? So the actual value, of course, that's the y. So then your estimation is according to your regression line, y equal to ax plus b. Okay, so that's your estimate y. So we subtract each other, that's our error. Typically, of course, error can be positive or negative. Okay, so that's why when we want to measure the smallest error, we need to make sure the error won't cancel each other. So the first thing, we square the error. So then we find the average for those square of error. Then we take the square root to change the unit back to the only one division. Okay, so this one we call the root mean square error. And then that's the symbol for the RMSE. So this RMSE for what? This RMSE actually tell us our estimation. If this number getting smaller, of course, that means our estimation value is skewed. That means our regression line is skewed. So that's why we back to our lecture file from last week, from lecture 31. So you remember those graph, right? So at the end of last week lecture, at the end, we show you, we using the graph to show you, here is the regression line we find. Okay, but to see how well our regression line is, then we demonstrate here, the red line actually is the arrow. We didn't show you everything, but we'll just show you 4 of the data. So then you can see that's the arrow. Okay, so when you try to find the RMSE, of course, we square all those arrows. Then we find the mean of the arrow. Then we take the square root. So then, yeah, that's the regression line. So after we have this regression line, from visualize, we can now really see how well it is, right? So maybe people will say, how about our slope a little more or a little less, right? So that's why we show you this one is from the calculation, we got the regression line. Okay, so then continue. Maybe we say, how about we adjust a little bit? We change our slope is 1500. Then the intercept is 20,000. So again, the same thing. You see, we show you, yeah, that's the arrow. Okay, so still visualize, we cannot see which one is better. Look like this one have smaller, but we are not sure. So that's why, yeah, of course we can do even worse. Yeah, we change the slope supposedly is positive, but let's see another negative regression line. So of course you did have much bigger arrow, but we need to using a number to represent, right? So that's why we define our root mean square arrow. Then we can calculate our root mean square arrow by passing your slope and your intercept. Okay, so then here, then you can see, right, we did see this one. We think they have bigger arrow, right? Their root mean square arrow is more than 30,000. Okay, so then compared to earlier, we try to adjust our slope a little bit. Okay, so yeah, so they are still over 11,000. Okay, so then the last one, of course, we check the regression line we find. Okay, yeah, so then, oh yeah, this one look like it's much better from, yeah, the first one. Okay, so then still better than the other one. We adjust the slope to 15,000. Okay, so then you can see this one, the our regression line, our root mean square arrow is less than 10,000. So look like this one is the better regression line. Okay, just like we say, we have our RMSE. Okay, we try to find the smallest arrow. So supposedly a regression line with the smallest root mean square arrow, that will be the best regression line, right? So right, what we can do is maybe we list few regression line, then each one we calculate the RMSE. But look like it's not a best efficient way, right? Okay, so things we talk about, we want to find the least square. Okay, you want to have your arrow in estimation to be smallest one. So that's we think we try to find the minimal value. So when we want to find the minimum value or maximum value, we call that the numerical optimization. Optimization always you try to find the smallest value or the biggest value. So the numeric minimization is approximate but effective. So how to find that? Okay, remember if you think about right, calculus help us to do that. Because when we have the minimized value or maximum value happen, the slope equal to 0. Using calculus, we can do that. So a lot of machine learning also using the numerical minimization as well. So in this class, we are not really using the calculus. However, we want to introduce you a function in Python we call minimize function. So this minimize function is what? Minimize function in Python, you passing another function. Okay, so we just call MSE is a function name. Okay, so MSE is earlier we say the mean of the square arrow. Okay, so this mean of square arrow, yeah, so give me your slope, give me your intercept. Okay, so different regression line, I have different MFE, but how to calculate the MFE is the same. So that's why we need to find a way to write a function to represent the MFE. Then we pass into the minimize function. They will return us what kind of the input can make the MFE is the minimized value. Okay, so that's the Python function we want to use. So how to use that? Yeah, continue to back to our lecture 32 file. Yeah, so here is what we didn't show you last week. Okay, so the numerical optimization, that's using the minimize function to demo. But before that, let's create a function. So you can see this function is y equal to x minus 2 squared plus 3. So we try to plug that. So you can see that's a quadratic equation. So this quadratic equation, where is the minimum value? The minimum value is here, right? Yeah, because y is the smallest one. Okay, so then you can see, right, x equal to 2. So then y equal to 3, that's the smallest one. So how to find that? Yeah, so here we just want to show you the function. But this function, we need to define that in Python. Okay, so we define an f function. You have the input is x. So of course, y equal to f of x. So that we return x minus 2 squared plus 3. So in order to find this point, you just need to call minimize function. Okay, we passing. So the minimize function, you passing a function, you want to find the minimum value. Okay, so that's why we passing f. So here you will see they only give you a one return value. This return value is the input from the function you input. So that's why actually it's x. So x equal to 1.999, almost 2, right? So yeah, this is where the minimum value happen. Okay, so that's the minimize function in Python. Okay, so we see this example. Of course, we can give you more example. So this one will give you a very complicated function. This function y actually equal to sine, then you have the sine, you have the x power to 3, x power to 4. Okay, so this function, okay, of course, let's define this function. We call it as a complicated function. So this complicated function, we already from the graph, we can see the minimize happening here. Yeah, almost here, right? Almost x equal to 0.05. Okay, we see if the minimize function can give us that. So since we defined the complicated function, okay, so we just passing the complicated function name to the minimize function. Okay, so then you see, right, yeah. So it's negative 0.51 for x, almost here. Okay, good. So using this minimize function from Python, we can find the minimize root of mean square error. Okay, so then how to do that? Yeah, so the first thing, of course, let's define our RMSE function. Okay, so this RMSE function input is what? Yeah, of course, give me your slope, give me your intercept. I will return you the RMSE, right? So of course, how to calculate RMSE is according to your estimation value. Okay, so then of course we need to give them the x and y. So then the estimate equal to the slope times x plus the intercept. So anyway, you call this function, you will return the RMSE. Okay, so that's why we see we provide 2. So that's the 2 function we have before, right? Okay, so then we just show you this function. We define this function correctly. Okay, so then from this function, how can I find the minimum RMSE? Right, we call the minimize function. We pass in the function name. Okay, so after you call that, so did you see the return become what? Earlier our return we only have one value, right? But now it's an array, you have 2 values. Why? Because this function RMSE you pass is 2 input. Okay, so since you have 2 input, so I return back to you is an array with these 2 input. So they tell us here is the slope, here is the intercept. This one will have the minimize RMSE. Okay, so we can plug in back. Yeah, we plug in back the slope and intercept. We back to the RMSE function. Oh, did you see? Right. So then the